Hello everyone, in this video we are going to solve a very simple circuit diagram problem. So the question says that in the circuit diagram given beside, we have to find the total strength of electric current flowing between the given points B and C. So let's start with the problem. Here there is a circuit diagram with many 3 ohm resistors connected in both kinds of combinations, parallel and series, and the total circuit is in attachment with a 3 volt battery, and we have to find the amount of current I which is flowing through the circuit. So let's begin by simplifying the circuit diagram first. So I am just trying to simplify the diagram. So here you can see there is a triangle kind of arrangement. So I would like to begin by drawing the larger triangle at first and then completing the smaller triangle accordingly. Okay, though it is looking like a triangle, that is there are 2 triangles, one smaller triangle and the bigger triangle, but actually there is only one triangle, and that you will get to understand in course of time. So now here is the point A and here is B and here is, listen carefully, that from this B there are these 3 wires originating, but actually there are not 3 wires, there are 4 wires. So actually if we just carefully look at this region, suppose, okay, so we will get to see here that there is actually 2 wires originating which are brought together and connected so that it is looking like 1 wire only. So basically we will just draw 2 wires from here, okay, and similarly 2 wires from here and 2 wires from here. So basically what is happening is that this portion, if I draw it like this, if I just apply a force like this in this direction, in this wire, the wire will stretch open in these 2 parts, in these 2 directions, and it will look like this, and that I have drawn here only. Okay, so basically I have just simplified the diagram. Now in this wire there is another resistance attached like this, and there is another resistance like this, and there is another resistance like this. Now actually we are trying to find out the equivalent resistance of the circuit, and after that we can apply simply Ohm's law and find the total current. Now in respect of B and C, we have to look at the resistors. Okay, so basically between B and C, if I just draw this point B and here this is C, okay, so basically there is simply one resistance like this, and each resistance is 3 ohms. So I am not writing the 3 ohms in each and every set, I will write it in the last step. Okay, and there is also another resistance like this between B and C, and these 2 are clearly in parallel combination because voltage is same. Now also these 2 actually, these 2 and these 2, if I just try to draw them, they will be like this. Okay, these 2 are here and there is one attachment point here. Okay, and there is one attachment point here, and from there originates to another 3 ohms which are in parallel. Now basically if I just draw another diagram, that is another simplified diagram, I will get something like this. Okay, let's draw. So basically here is B again and here is C again. So there are 2 parallel combination of 3 ohm resistances. Okay, there is one parallel combination involving 2 3 ohm resistances, and there is something like this. Okay, something like this. Okay, basically something like this. Okay, so basically here there is another 3 ohm and here there is another 3 ohm. Now what is happening is that all these are meeting at this point, and this point is basically C, and this point is basically what, B. Okay, now I am just now drawing the final step diagram, or the most simplified diagram which can be drawn. Okay, so the final diagram will look somewhat like this. That is, these 2 are in parallel, and also there is another 2 which are in parallel like this, and these two parallel are in series, and the this total part is in parallel with another 3 ohm which is again in turn parallel with another 3 ohm. Okay, and here is the point B, C, and if I just mark A will be somewhat like or somewhere like here. Okay, so basically now I am writing 3 and 3 and 3 and 3. Okay, so basically these 2 are in parallel, these 2 are in parallel, so basically we can remove them and write the equivalent resistance. So for 3 and 3 parallel 3, we get 1 by R equals to 1 by 3 plus 1 by 3, that is 2 by 3. Okay, that is 1 by R. So R is what, 3 by 2, so we can just replace it by 3 by 2 resistance, and similar case will be done for this side also. Okay, so we can just replace this by 3 by 2 resistance. Okay, so 3 by 2, and these 3 by 2 are basically in series combination, so we can just again remove these 2 3 by 2s and replace it by the series combination of 2 3 by 2s which is nothing but 3, because 3 by 2 plus 3 by 2 is 3. Now clearly given picture can be simplified as a parallel combination of 3 individual 3 ohm resistances. These 3 individual 3 ohm resistances will give R equivalent, final R equivalent as 1 by 3 plus 1 by 3 plus 1 by 3, which is nothing but 3 by 3 or 1. So R equivalent will also be 1 by 1, that is 1. So we can just replace these 3 by a single resistance. Okay, these 3 by a single resistance, single large resistance, which is nothing but 1 ohm. So the final resistance between points B and C is 1 ohm, and this point B and C is attached with a 3 volt battery. Okay, 3 volt battery. So here is 3 volts and I current is flowing. So basically from Ohm's law we can write V equals to I times R, and here we know that V equals to 3 and R equals to 1. So basically if I do the calculation here, we will get that I equals to V by R, that is 3 upon 1. Okay, that is 3 upon 1, that is 3, and the unit will be ampere, that is volt per ohm. This is the final answer we have got, and so the total strength of current flowing through the given circuit is nothing but 3 ampere. So hope you all have understood the video very clearly and very well.